Yeah, half a recording. It's okay, I don't know that anybody's really using them too much, but. Okay, we want to write each expression as a single logarithm. So we're still using the log properties here. So let's say, and we're only going to do one of these because there's only one of them. 3 times the log base 4 of x plus 1/2 log base 4 of y minus 2 log base 4 of z. So I have 3 log base 4 of x plus 1/2 log base 4 of y minus 2 log base 4 of z. So it's written as a bunch of different expressions. I want to combine them all together into a single logarithm. So I'm just going to write the word log one time, and I still have to keep the base 4. So I have log base 4. Okay, and then I'm going to have some stuff after it. Because I see a minus sign, I automatically know that I'm going to have things in the numerator and stuff in the denominator. So I'll draw my fraction bar in. Okay, what does this log 3 times the log base 4 of x translate into?
X power 3.
Yep, x to the 3rd. Okay, what about the 1/2 log base 4 of y? That's going to translate into?
X to the -2?
Not -2. Fractional exponents are radicals, so that would be the square root of y. If that had been a 1/3, I would have a cubed root. If it had been a 1/4, I would have had a 4th root. So again, fractional exponents are always radicals. Okay, what about the last term? Where's it going to go?
On the bottom.
And it would be z what?
To the 2nd.
Yep, z squared. And you're done. That's it. That's all you got to do. So not a lot of work on that problem. It's just pure, just writing it down more than anything else. So, comments or questions? And only one of those, just one.
I'm good.
Okay, thank you. Okay. Then we're going to start solving. So, and I think there are 4 altogether on the exam, but they're scattered because of how they fell in the sections. So I'm going to group them all together, but I think there's 4 of them. So let's do 8 to the 6 plus 3x equals 4. So 8 raised to the 6 plus 3x equals 4. Okay, now there's an easy way to do this problem and there's a hard way to do this problem. I want you to see the easy way, and what you're going to recognize is that both the 8 and the 4 can be rewritten as a base of 2. So in other words, try to take them to the same base if you can. So 8 is really 2 to the 3rd power. And then I'm going to put the 6 plus 3x in parentheses. So I have 2 raised to the 3 times the quantity 6 plus 3x. On the other side, 4 is 2 squared. And now that we've done that, what do? Remember?
So equal the exponents to each other.
So we're going to take those 2 exponents and set them equal. So 3 times the quantity 6 plus 3x is equal to 2. Yeah. So then we'll distribute. So 18 plus 9x equals 2. Or 9x equals what? A -16 when I subtract the 18. So x equals a -16 over 9. So not a very pretty answer, but it definitely works. And you could check it. You could use your calculator and check it really quickly by plugging it back into that x. Comments or questions?
How did you get 3 parentheses 6 plus 3x equals 2?
So from the previous line, we know that that 8 is this 2 to the 3rd, correct?
Yeah.
Okay, so then what I'm going to do is I'm just going to pick up the exponents on both sides. So I'm going to pick up this 3 times 6 plus 3x, and then I'm going to pick up this 2. So what we're doing is just using the exponents alone.
Okay.
Okay, and then solve it from there. And in general, anytime I review, my problems are going to be more complicated than the ones that are on the actual exam. Because if you can do the harder stuff, the exam should be the easier stuff. So, Okay, now that, don't get confused with this kind of problem. So what if I want to solve 5 to the x is equal to 3? So 5 to the x is equal to 3. So still got exponents, just like this one does. But what I'm going to notice it is instead, there's no way to make a 5 into a 3 or a 3 into a 5. Again, back over here, both of these could be rewritten as a 2, right? But there's no way to rewrite either of these as a smaller number raised to a power. So in this case, we have to go a different route. Then we know what we're going to do here.
Go to the log form.
Yep, that's exactly it. So you can translate into a log form, or you can take the log of both sides. It's your call. I'm going to go ahead and, because you said it, we're going to switch to logarithmic form. So this would be log base 5 of 3 equals x, and then I'm done. That's it. That's my answer. Because x is by itself. Okay. Now, if you didn't recognize that that's what you needed to do, so this is a big or, you could have gone this route with it. Part of it's just a matter of how you think about it. I can take the log of both sides because the log is an operation, something you do to a number. And when I do that, I can then move the exponent out in front. And then divide out the log 5. So I end up with log 3 over log 5. And on your calculator, this answer and this answer are equivalent as far as decimals go. So either way will work. It's just your call. Which one you feel more comfortable with. So you're going to have one of each type. One where you can make the bases the same, and then one where you cannot make the bases the same. Are we good?
Yes.
And then we're going to have 2 log equations to solve. So let's say we had same direction still solve. I erased my directions. Log base x of 64 equals -3. So log base x of 64 equals -3. And I need to solve that one for x. So suggestions, what can we do? So the x is kind of trapped inside that logarithm. So to get it out of the logarithm, you have no choice, you have to switch forms. So when I switch forms, what's the base?
X
Raised to the
-3
equals?
64.
Yep, beautiful. Okay. So this one's a little ugly because of that negative exponent. That really means that that's 1 over x cubed equals 64. So just handling the negative exponent. There are lots of ways you can interpret it, but I think this is the most straightforward. At this point, I'm going to cross multiply to get the x back into the numerator. So that would give me 1 equals 64x cubed, or x cubed is equal to 1 over 64. And then to get rid of the cube, we're going to cube root both sides. So x is equal to, the cubed root of 1 is 1, the cubed root of 64 is 4. So it turns out that x is equal to 1/4. So this would be log base 1/4 of 64 equals -3. Comments or questions about that one? Okay. And then the other log one, let's say we have the log of the quantity 7x minus 12 is equal to 2 log x. So the log of the quantity 7x minus 12 equals 2 log x. So definitely a different looking problem. But I need to recognize that the difference between these two is over here you have log equal to a constant. Here we have log equal log. So again, the approach is very different. what we're going to do is bring this 2 inside first. So my very first step is to make sure I have no coefficients, that everything is moved inside the parenthesis. And if I had more than one term, I would write them as a single logarithm, but yours on the exam is similar to this. So, okay, at that point, what are we going to do? I have log of the quantity equals log of a quantity. Anybody remember? Okay, well, because there's a log on both sides, you can just come in and set those the insides equal to each other. So we're going to 7x minus 12 equal to x squared. And that was a log property, that if log base a of m equals log base a of n, then m equals n. So again, you just set the insides equal. So that's why you have to get them as insides first. And now you're down to a quadratic. So this is x squared minus 7x minus 12 plus 12. Make sure you do your arithmetic correctly. Okay, we're looking for factors of 12 that add to 7. So x minus 3 and x minus 4. So we get x equals 3 and x equals 4. And then don't forget, you do need to check these because they're logarithms. So I'm going to plug each of these back in to make sure I get a log. Take a log of a positive quantity. So if I plug 3 in, 7 times 3 is 21. 21 minus 12 is positive. If I plug 4 in, I'm taking the log of 4, which is still positive. So everything works out fantastic. You get 2 answers, which is a little unusual, but again, you cannot take the log of a negative, so that's what you're trying to avoid, is a log of a negative. Okay. Comments or questions about solving each of your logarithms? Nope. Okay, and that should be all 4 of the solving. Okay. And then the last 3 problems on the exam are application problems. So in terms of the application problems, and again, there are 3 of them. So you need to make sure you've got your formulas memorized. So if you have compound interest, there was no way for me to figure out how to give you the formula, so you just need to memorize it. So A equals P times quantity 1 plus R over N to the NT power. And then if it's continuous interest, that one's the easier one to memorize. That would be A equals P e to the RT, and that one's easy because it spells out a word PERT. So much easier to do. Okay, you're gonna have one of both of them. So you will need both of these formulas, and you might be solving for different things. So make sure you're reading carefully. And then you also have exponential growth. And that's basically the PERT formula with different alphabet soup in it. So A naught e to the KT, but it's the same thing. If you just want to call it PERT, you can. You just recognize that P, or A naught, is the amount you have at the beginning of time, and then the left-hand side is the amount that you have at the end of time. You will not have an exponential decay. You'll have one compound interest, one continuous interest, and one exponential growth problem. Okay, that's all I got. So do you have any questions for me? So I don't know whether you started that review yet or not, but
One thing that I got confused in was an example on Pearson was when we raise like the n, the amount of time to a negative. Like why do we transfer that? Why do we make that a negative when multiplying
Yeah.
out?
okay. So, and I think what you were doing is this kind of problem, and what you're doing. So I know exactly what you're talking about. So A is the future value of the account, and P is the present value. And so what the question is asking is they want you to find the present value given the future value. In other words, if I need money in 10 years to do something, go to Hawaii finally, how much do I have to have now? So if I want to take this formula and solve it for P, then I would have A all over 1 plus R over N to the NT would be equal to P. So does that make sense? If I just divide both sides by this, it would move it over here. But if I want to rewrite this so it's a little bit more user-friendly, then I can take the stuff in the denominator and give it a negative exponent to bring it up. So the only difference between the two, literally looking at them, is the sign on that exponent, right? So what this is saying is if you're starting off with a bigger quantity and you need to get it to a smaller quantity, you give it a negative exponent because it's a decreasing function. If you want to start off with a smaller quantity and get it to a bigger quantity, then you need a positive exponent. So that's why it has a negative on the NT, is because you're looking for the current value given a future value. Okay, does that click in terms of what they're asking?
A little bit, yeah, but
Little
it seems
bit,
to make
yeah.
sense.
I'm looking at what, find the amount, the results, continuously, find the principal now. So yes, so you're gonna do this kind of question. So they're gonna ask you, they're gonna give you the future amount and ask you for this. So this is what you need to find. Do you wanna walk through one of those? Because I wouldn't do it like this, right? I would work it from this formula alone.
Please.
Okay, so. Okay, so I'm going to use their wording. So let's find the principal needed now to give, and now I'm just making the numbers up, $2,000 after 4 years, compounded quarterly. Okay. Yeah. And then it says, they say, that is, find the present value. So that's the wording from the actual exam. So I've changed the numbers, but that's it. Oh, we need the interest rate. 4 years, compounded quarterly, I don't know, let's do 3%. Because we need the interest rate in there. Okay, so I'm gonna go through and identify what they've given me just so I know what I've got. So A is the amount at the end of time. I know that's the $2,000. P is the amount at the beginning of time, the present value, and it is unknown. So I'm going to put a question mark there. The interest rate is 3%, so that's 0.03. The time is 4 years. And N is how often is compounded, which for us quarterly means what? So what does that mean? Quarterly. How many quarters are in a whole?
4.
Yep. So I got a couple of 4s floating around there. Okay. So to set up the formula, we're going to have 2,000 equal to P times 1 plus 0.03 divided by 4 raised to the 4 times 4 as an exponent. And we need to solve this thing for P. So what I would do is come in and take all of this and make it into a decimal on my calculator. So and if I do that, I get 1.126992114. 1.2699214. And then all I have to do is take 2,000 and divide by that decimal. And I don't want to round it anywhere. I want to carry all those decimals until the very, very end and then do the rounding. So I'm going to let the calculator carry the decimals and just divide by the answer from the previous line. And I end up with 1774.64. Okay. And there it is. So you see, I didn't use the negative exponent anywhere. I could have raised this to a negative 16 and just multiplied by 2,000, but to me, it's just easier to let the calculator carry the decimals. So.
Yeah, I think I just get lost on it because I'm assuming that I'm seeing a negative and no other negative to counter it. So I
To
would.
counter it, yeah, but a
then I
negative on
lose
the
it.
exponent simply makes that quantity tinier. That's all it does,
Oh, okay. Huh.
right? So a negative exponent moves something to the denominator, which makes it into a fraction, which makes it smaller.
Oh, right.
Yeah, so yeah,
Okay.
I understand where your confusion on that negative is, so. Okay, any other comments about the upcoming exam?
I'm good after that.
Adam, Matt, Christina, are we good?
Yeah, I'm good.
Yeah, I'm good.
Okay, so I will be here tomorrow again at 9 as normal. If you have any questions, if nobody's logged in by 9:20, I'm logging out. I'm calling it good for the day. And again, if you need to reach me immediately, send me a text because they usually always have my phone with me, so I can reply to text a lot quicker than email. So, and then on Wednesday we'll meet again and talk about the final exam and do some questions for the final exam. So, anything else?
No, that's it.
I'm good.
Okay.
Good.
Have a great day. Enjoy it. Be
You
safe.
Thank you.
You too.
Bye-bye.